Welcome to Domain 1 of the CISSP masterclass that we've developed over the last couple of years. This is the domain called access control, which is one of the most important domains in the CISSP CBK. This is concise and without any verbiage, trying to get through all the topics and get to the point. What I actually do on each one of these domains, I'll go through what IC² defines for the candidate information bulletin, what we need to do and what the domain contains, so that you need to be aware of where we're going with this and what you have to learn. The learning objective here is that access control domain covers the mechanism by which a system grants or revokes the right to access to data to perform an action on an information system. File permissions such as create, read, edit, or delete on a file server. Program permissions has the right to execute a program on an application server. Data right, such as the right to retrieve or update information in a database. The CISSP candidates should fully understand access control concepts, methodologies, and the implementation within centralized and decentralized environment across an organization's computing environment. Now, when we look at some of the access control definitions, let's go through a couple of topics so we understand and all speak the same language. Access control is the process of limiting access to a resource based on a predefined set of rules at a specific time. And that at a specific time is very important because sometimes you need access and sometimes that access has to be revoked to ensure that there's segregation or separation of duties. Also, that access control are a collection of mechanisms that works together to protect the information assets of the enterprise from unauthorized access. The objective is to ensure confidentiality, integrity, and availability. And Little Thinking Man identifies to us that we need to sometimes consider, when we look at something, to look at the threat at the same time. For example, and there are slides later explaining this exactly, confidentiality, threat is disclosure, integrity is modification, and availability, the threat is destruction. So access control allows management to specify which user can access the resources contained within the information system, specify what resources a user can access, specify what operations a user can perform, also specifies at what time the user can have access to authorized resources, provides the accountability to a user and actions, and this forms the basis of a trusted computing base, as we'll see later in the Department of Defense Orange Book criteria, the TC-SEC. Also, the security is the process of protecting the protection of resources against unauthorized modifications, disclosures, and or destruction. Reliability means the guarantee that the reference monitor, which is like a traffic cop, will be invoked for every call from a subject to an object. There's some scalability which means that the ability to cope with growing security demands without a bottleneck being introduced. Least privilege means that we limit a subject to an object to only those resources required to complete the job or the function. The segregation or separation of duties, which is the process which requires more than one subject to complete an action of value, resulting in requirement of collusion to commit a fraud. Also, information classification. There we need to consider, do we have an organization? What does it mean to us? The disclosure, the destruction, and the unauthorized modification. What financial impact or embarrassment factor will that have to organization? Security policy, it's first and foremost core item that we require before we start anything. Look at an access policy, a security policy, an acceptable user policy. We'll go through a couple of items like that. The need to know or the need to have, and not the dying to have. The dying to have is usually what people want, administrators think they require, and most certainly developers are very guilty in this. Granularity means the fineness of the control. So the more granular, the more we can control the access. Reference monitor, I said, is a traffic cop where everything has to go through. If this is bypassed, we have a failure of an access control system. A subject is normally a user, and it can be an application such as in the Windows environment, a service account, and an object is a resource that the subject would like to access, such as a data set or a printer or a file. Another thing that we need to consider when we look at personnel, access control, and this goes through everything from BCP, DRP, physical security, where human life is at stake. We need to consider the priorities needed for users, operators, and business partners. It is important when you look at any question. Information systems can be anything from legacy, that's old systems running that we don't have a replacement for or it's no longer supported. Current and future considerations, so we need to consider these from an access control point of view, specifically when this tie in and you'll see later with architecture and design in organizations. From an access control point of view, we need to consider a facility such as power grid, access to that, water supply, heating, ventilation, and air conditioning, and also telephone systems such as PBXs and PADXs. The first one digital, the latter analog. And also when we look at process identification, authentication, authorization, and auditing. Identification is a single instance of a subject. That is like your user ID. The authentication is an attribute or a process ensuring the claim of that subject, you being the subject. Now, authentication can be a password, as an example. And then when that user ID and password is correct, a certain process in the background, such as authorization, will take place, which is a process of granting rights from a subject to an object. Then once you log in, hopefully auditing should take place. This is really important when we look at accountability through systems at certain level of security settings. So auditing is the verifiable and accountable steps to a single identity. Now, what I usually suggest is instead of going through the complete Orange Book, which is covered in the security architecture and design explicitly, I recommend using to read an article or document called Not the Orange Book, which is located in the handout pack called ntob.zip. This will allow you to understand the Orange Book in detail without needing to go through the actual reference. I think it's taken from about 400 pages down to about 90 pages. Now, access control in a system's lifecycle is important. We have the few phases, such as the initiation phase. During the initiation phase, we need to acquire key reference materials, such as policies, standards, procedures, and guidelines. Often, some legal documents from a country would be required to give us input. Specifically, if you work for an organization such as the Department of Defense or where you work with critical data. We need to do asset identification, and as we know, this is a really difficult step in organization because this is in flux, and also assets can have different value to third-party, black market, or competition during its life cycle. We need to make sure that we have a security classification policy within our organization. This means that we can take an asset and assign a value to it based on the exposure and the threat level. Then we need to define rules of behavior based on the access control from subjects to objects. Then the second phase, the acquisition or development phase, we're going to do a risk assessment, a cost benefits based on that risk assessment, and then develop compensating controls and also security and test evaluation plan. You need to determine and prove that things are working as designed. So you have gone through the implementation and testing phase and have results. The implementation phase, we're going to implement the selected security controls. Then, if required, for example, such as in a bank, we have PCI, the Payment Card Industry Standards. We'll assess certification and accreditation. The next phase is operation and our maintenance phase, whereby change control and configuration management is really important to ensure that we don't do any changes without proper testing, documentation, and approval. We're going to have a continuous monitoring and reporting of our access control. And hopefully this is also going to a war room kind of scenario where if anything goes wrong, people can review it. They can look at a trend analysis and incident response on that. And then the disposition phase from an access control in a system's lifecycle. The disposition phase is really important. Backup and documentation, sanitization and documentation, and then finally destruction and documentation is really important. As you can see, the documentation phase is done to ensure that we apply to possibly compliance requirements, proving that we have destroyed the data and proving that the data couldn't get into anybody's hands. It's not part of the process. Now, one recommendation I can do is to look at the security considerations in the information system lifecycle. There's a document, there's a link there, you can actually look at it. This is in the federated systems. So it is one of the NIST documentation, SP 800-64, and it is available on the information pack that you have. Usually when I actually look at organizations, I ask the question if they have an organization, the organization has a security classification policy. If the answer is no, then we need to understand that this organization does not have any security at all. They may think so. The problem is if you don't classify information, you don't know where to start. You don't know where to put your money in. So you have to have a classification policy that has been approved and implemented and pushed right through from beginning to the end. As part of the information classification, if we look at the policy, we need to identify each asset and the value of that asset along with possible threats. We need to define the possible loss in case of a threat realization. We have to define the level of protection required based on the asset value and that exposure realization. Now, also, when we look at classification, we can look at public, confidential, secret, such as commercial classification. Then also there can be military, such as unclassified, sensitive but unclassified, confidential, secret, and top secret. Now, the classification process is as follows. We have to look at the data classification objective. That's part of compliance. Then organizational support from a top-down approach. Step 3, we have to develop our classification policy, then supporting documentation such as procedures, standards, and guidelines. We have to develop or identify the application owners. Then we have to identify, and step 5, the data owners, because they are different. They can be the same, but they are normally different. Step 6, we have to develop auditing procedures. This is part of the assurance procedure to make sure that we have done things correctly. Step 7, we have to log this information to a central repository. This could be, for example, a configuration management database with a risk associated. Then we have to train the users. And then an annual process, or when we define the anniversary, it can be 180 days, review and update the information classification. An example you can look at is the Department of Defense 5200.01 Information Security Program. It's defined in 4 volumes. There's a link you can download if you want to look at it, to just look at further information. And the 4 volumes, volume 1 is the overview, the classification and declassification of information. Volume 2 is the marking of classified information. Volume 3, the protection of that information. And volume 4, controlled and classified information. So have a look at that if you can. Take some of that information and apply it to your organization and also part of your learning process. The access control categories and types, if we look at that, there are objectives to make sure that the confidentiality, the integrity, and the availability of system and data, such as unauthorized access, unauthorized disclosure, unauthorized modification, and also destruction and denial of service. We have to protect the information against those threats. Now, there are operational or physical controls such as lock and key, security guards, technical or logical controls. These are things that we can't touch usually, such as passwords and encryption. And then finally, management or administrative controls. These include things like policies and procedures. In information security, from an access control point of view, it will be things like security awareness and training associated with that. There's some access control types. We've got preventative controls. This prevents an unwanted occurrence from happening. We have detective controls, where we have identified an unwanted event that has been taken in place. Corrective action, where it resets the status quo to the desirable or in the previous working instance. We have deterrent controls, which to discourage security anomalies from occurring. And finally, recovery controls. This restores resources and capabilities after a security anomaly has been occurred. There are also compensating controls, which are additional controls to lessen the overall risk. So inherent controls is with compensating controls, I would equal resultant or residual risk. Now, when you actually look at these, preventative and detective controls are pre the incident, corrective controls that are during the event. The deterrent controls can also be pre, and recovery controls is post an event. Here's a couple of examples, and what you need to do with these examples, these are management or administrative examples. We have directive, preventative, detective, corrective, and recovery examples, and each one of these. And the interesting thing for me, the directive control is such as policy or guidelines here. We have preventative control, such as user registration, so we get all the information, user agreement to make sure that the data doesn't get disclosed, and then we'll have a non-disclosure agreement. On top of that, we will have separation of duties to make sure that fraud does not take place. We can have warning labels and banners. As part of the detective controls, we can have review of access logs. Now, as you can see, this is usually during or post the process. We can have job rotation. We can have investigation to make sure and determine what issues were done, if any fraud took place, for example, and then security awareness training. Now, this can be detective purely because your awareness training will allow users to understand what the risks are, detect it, and then create an incident on top of that. Corrective examples can be a penalty, administrative leave to get the guy off the system so you can investigate, control termination processes to make sure that we actually do disable and do make sure that all access to data is removed. Then from a recovery example, we have business continuity planning and disaster recovery planning. Operational physical examples, directive, we can have procedures, preventative controls, we can have physical barriers, locks, badge systems, security guards walking around, and security guards are usually selected when somebody has to make a decision. Man-trap doors, you've seen that usually at your bank, effective hiring practices, so we can make sure that the checks and balances have been done. Does he have a police clearance? His creditworthiness, if we're in a banking environment. And then awareness training is also part of preventative, again, from a physical operational point of view. Detective, monitor access, motion detectors, closed circuit TV are examples. And you can take many of these and to try to think about examples in your environment. We have corrective control, such as user behavioral modification. And what this is, it could be, for example, a private sign on a door. So people should not go into a room that is defined as private. Modify and update physical barriers, reconstruct offsite facility as part of the recovery process. When we have technical examples, we have standards there. Preventative controls can be user authentication, multi-factor authentication, access control lists, firewalls, intrusion prevention, and also encryption. When we look at detective controls, as a couple of examples, log access and transactions, so we review that. Store access logs in a remote system so they can't be hacked into if the system is hacked. Simple network management traps, intrusion detection, and also then MAC and hashing on files if they are changed. And we can actually detect if they are changed. Corrective actions, we can isolate and terminate connections, and that's usually intrusion prevention systems. Modify and update access privileges, can be role based on an identity basis. Now, recovery, we can have backups, recover system functions, and then also, and what I say to the guys usually, if a system is compromised, what is the best action you have to take? And usually I say it is a rebuild. Sometimes very difficult to do. However, a rebuild will ensure that you actually get back to your status quo. Now, let's look at some threats and measures when we look at this. An example of threat could be network penetration. And when we look at network penetration, the detective control from a technical point of view can be intrusion detection, a timeous review of logs, forensic analysis. When there's a physical threat such as break into premises, a detective control on the physical side will be guards, motion detectors and video cameras. Fraud by staff can be administrative control in a detective control, such as audits, job rotation, workflow, capture, and release. More threat examples, and this is not an exhaustive list. Denial of service. There's things like ping of death, very old technology, smurfing, SynFlood, distributed denial of service. Unauthorized software, it can contain malicious code or mobile code. Software defects such as buffer overflows. Covert channels, trapdoors. Physical threats such as unauthorized physical access could be things like dumpster diving. And I often ask, is this legal or illegal? It all depends. If it's trespass onto your premises, it's illegal. Otherwise, it is legal because you didn't deem any value into whatever you threw away onto the rubbish bin or into the dumpster. Shoulder surfing and eavesdropping. Electronic emanations, also a physical threat. And you can look at controls such as Tempest, personnel or societal engineering threats. Disgruntled employees, careless employees, can be targeted for data mining such as browsing, spying, and impersonation. Now, the ping of death, although it's an old technology and sometimes not used anymore, purely because of the buffer problems that are patched, and the programmers are starting to look from an operating system point of view, starting to close these things. It's part of the denial of service. And the way this happens is, at the end of the day, the underlying problem is a buffer overflow. Now, a ping is a packet that is sent to a system, and it has an echo request. And a system that receives a ping will take that packet and copy it to memory to send it over again. Now, programmer error does not check the length of that buffer that comes in that it has to send back. Now, there's a limited amount of space in memory for that ping, such as, say, 10K, 10,000 bytes, and somebody sends a little bit more or just over 10 bytes. This system will take that 10,000 plus n bytes and try to copy it over in memory, because it has to copy it to memory to send it out again. It has to know what it's sending and using another call. It will take that larger than acceptable area bytes and actually write it over. So it will overwrite certain areas in memory that it doesn't have access to. When this happens, normally a kernel panic in a Linux or Unix environment will take place. A blue screen of death will happen in a Windows environment, as this is outside the control of the reference monitor. And when that happens, the system upends or abnormal ends, and many systems were susceptible to this. This, at the end of the day, is part of programming error. What you can do is apply the latest patches, and also to configure host-based firewalls to block ping requests, ICMP echo requests. Then smurfing. Smurfing is also known as ping ICMP storm or ping flooding. This is when an attacker will change the source address from the packet being sent out to the address of the IP he wants to attack or flood. Then what he will do is send a ping to a network and not to a single host. And some networks are incorrectly configured that allows this. This normally is not the case, but some networks have that problem. So what will happen once the ICMP echo request or the ping is sent to a network, the whole network will respond to the defined source address, which is somebody else. And this can flood a single and attack and do a denial of service on a single IP address. What you can do is disable IP-directed broadcast on the routers using ACL, and also configure host-based firewall or server operating systems to block the ping request. Now, SYN-flooding is where you have a three-way handshake in a network connection. The client systems will send the SYN or synchronization message with a spoof source address to the server. The server will respond by sending an acknowledgement message. However, since the return source address is spoofed, so the server will never get to complete that TCP session. And since the TCP session is a stateful protocol, the server stores this half-open session. If the server receives a false packet faster than the legitimate packets, then a denial of service may occur, or the server may exhaust memory and crash for a buffer overflow. So to counter this, we can actually, for attacks originated from outside apply the bogon and private IP inbound ACL to the edge perimeter, the root tool's external interface. For attacks that originated from inside, permit packet originated from known interior IP addresses to outbound ACLs on the edge router's internal interface. Then a distributed denial of service basically requires an attacker to have many compromised hosts which overload a targeted server with network packets. Now, we've seen quite a few of these, what they call botnets, and hackers will create botnets and actually sell this to other people that want to perform a denial of service attack. Now, when a botnet is created or a back end that you can control, such as a Trojan application, is placed on a remote computer, this waits for a command to be woken up, and this is known as a zombie. Now, what you can do is you can harden your service to ensure that only services running that should install host IDS to prevent them to become zombies. Also, you can set up network intrusion protection systems at the edge or perimeter of the network, and also you can do active monitoring of host, network IDS, and also network IBS and syslogs for any anomalies. Now, also another thing, malware threats. Viruses are programs that attach itself to executable code, so it needs a host, and it is executed when the software program begins to run on an infected file is open. Also, it may have a payload that may be destructive, and if it is destructive, it will take a while to propagate first before it's activated. Worms are programs that reproduce by copying themselves to computers on a network. The primary objective of a worm is reproduction. A Trojan horse is code fragment that hides inside another program and performs a disguised function. And a logic bomb is an application that releases some type of malicious code when a particular event occurs. Now, there are other issues like macro viruses that can be written by Visual Basic for application or other macro languages. Trojan and worms, we've seen that. Instant messaging attacks, and we've seen that happening on your cell phone in mobile code more and more so. Internet browser attacks such as Zeus, that is a banking Trojan application stealing your code. Malicious Java applications, malicious ActiveX controls, because an ActiveX control is basically a DLL or dynamic link library that becomes part of the operating system within a browser. Email attacks such as phishing. There's also issues such as farming and waiting, and that is phishing but directed to a specific host and organization or individual. A buffer overflow occurs when a program or process tries to store more data in a buffer, which is a temporary data storage area, than was intended to hold. This vulnerability is caused by a lack of parameter checking or enforcement for accuracy and consistency by the software application operating system. This is bad programming, totally bad programming, and this is the primary cause. Countermeasures, we can have good system development lifecycle process such as code inspection and walkthrough. We can apply a patches and operating system for application, and also we can implement hardware states and controls for memory protection, and it depends on the operating system, buffer management of the operating system. We've seen it so more and more so in the later operating systems. Programmer implementing parameter checks and enforce data rules on every parameter that they do. Memory access threats, we have to have memory protection. This is an enforcement of access control and privilege level to prevent unauthorized access to operating system memory. Many of the later technologies within the CPU, such as the AMD and Intel, has got that new bit set. So if any data wants to come from data and be copied to the execute portion, it will be detected by the CPU and discarded. Now, other issues we can control, such as countermeasures, we can ensure that all system-wide data structures and memory pools used by the kernel mode system components can only be accessed while in kernel mode. Kernel mode also seen as supervisory, administrative, and system mode. We can separate software processes to protect private addresses space from each other process. We can hardware control memory protection in the CPU, as I mentioned, and then also use access control lists to protect shared memory objects. And also what you have within a system architecture in the bus, in the computer operating system, you have what they call the hardware abstraction layer, or HAL. We'll see it later in slides, but this is also to make sure that we can't directly talk from the application right through to the direct memory address space, the DMA. A covert channel is an uncontrolled information flow or unauthorized information transfer through hidden communication paths. We may have it through a storage channel. An example I can give you there, if I'm a hacker and I work in collusion with another user, and I need to know when to execute an application, but he needs to communicate to me, and the only way he can do that is by changing a date or timestamp on a file that we both have access to at the same time. This is a storage channel. Information leakage can occur through a storage channel like that. Timing channel, an example I can give you here is time of check or time of use. If a user changes his password on a Friday because he either forgot it or it has to be changed and he phoned help desk, and help desk change it to the standard password that is used by the organization. Now, this is often the case. If I know that there's a standard password, I can actually scan all users in the domain and try the default password on a user. This is a time of check, so I'm going to use it before the user uses time of use. Now, countermeasures, and it's simplistic steps, but it's a very difficult objective to maintain. We should identify potential covert channels. Now, if it's a covert channel, we don't know about it, but so we need to investigate that. We have to verify and validate the existence of that channel, and then close the covert channel by installing either patches or packet filtering security mechanisms, or lock down the access control. Now, within the authentication techniques, we have something you know, such as a password, PIN, or passphrase, something you have, such as an ATM card, smart card, token, key, badge, or your passport, something you are, such as biometrics. We can have fingerprint, voice recognition, iris scan, retina scan, DNA, gait, and facial recognition. Now, the gait there should be actually G-A-I-T, and that's the way you actually walk. This is your length of your steps and what they call the cadence of how many steps you take per minute. Or then also multi-factor authentication. A user has to present 2 or more authentication techniques for access. Tokens such as one-time password. Now, this is more common these days because we mostly log on to banking and we get that one-time password. We have to pay money to a beneficiary that's not within our system. This is something generated from a random number generated. That's a device that generates that one-time password. A synchronous token can be counter-based token, such as an RSA token, clock-based token, such as a Kerberos token, asynchronous token, a challenge response device such as a token card or a grid card, a smart card with memory or processor chips that accepts and stores and transmits certificates or keys that generates those tokens. This is required from FIPS 201 PIV, and the documentation is in your information pack to go through if you want to a little bit more technical details. Now, the problem with passwords is they are insecure. Users will select easy passwords, easy to remember passwords. And when I do a password audit, I usually determine from the first password the top 100 passwords an organization will use. If a water board, a lot of the passwords will actually start or have something to do with water in the password. It's also easily broken, such as dictionary attack, brute force, or rainbow tables. Now, rainbow tables, if you want to look at that, is OPH Crack is a website you can go to, download the single table that can actually crack Windows passwords by inserting the CD. You can also crack these online, and it is very easy to crack a password within a few minutes. It's inconvenient because a user will write down if it's hard to remember, and it's reputable, which means there's no real proof of authentication because people can share it. Now, access control threats, some threats we can look at. There's shoulder surfing, somebody looking over your shoulder, looking at your password. There's dumpster diving, and we must make sure we can shred these things. We can have a denial of service or even a distributed denial of service. Buffer overflows, for example, a noob attack. A noob attack is non-operation points, and you can look at an application such as Metasploit, which will create these exploits, and you can actually look at the examples such as noob attack. I highly recommend Metasploit to be reviewed and download that and see actually how it works. Network sniffers, we can look at possibly encrypting the data using IPsec as a free and or inherent control within an organization. Object reuse, data remnants. This is where I create a password in memory and I don't overwrite it before I release the memory. So if I don't do that, the data of the password will still be there and I can get into it. A deadly embrace or race condition is a condition that puts a CPU based on access control in a high or 100% utilization. There's backdoors. Good examples. Programmers have developed backdoors in applications to get access and maintain those without going through proper change control procedures. An excellent example is the database system called Interbase. Now, Interbase is a SQL type of database that were called Starbase initially. Came with the time where I think Borland bought Ashton Tate. And at a point in time, Interbase was made open source, and this came into the market. And then when it was open source, people realized that inside the code, there were hard-coded user ID and password for system maintenance. So you have system access using a hard-coded user ID and password. The user ID was political and the password was correct. And this is up to 604, and anything from version 604 and before had to be patched to ensure that that has been removed. A trapdoor that we saw earlier is depending on a condition. A condition might be if I work for an organization and I actually have devious intent, I can write an application to look at the HR database to see if I'm employed. And while I'm employed, it will check every day and do nothing. And once I'm not in employment of the organization, we'll wait a while and most probably delete files or anything like this, either for revenge purposes or create more jobs for myself, try to get myself back into the organization. Now, I don't say do this. This is a very good example. SQL injection, the biggest threat on the internet at the moment, and identified with many security houses as the top 10 threats. And this is all again programmer error. A Trojan horse is an application pretending to be one thing, but it actually has got devious intent. A logic bomb, also based on a condition. If a certain condition is met in the system, something can happen negatively. Social engineering, my biggest threat in organization. And how do I combat social engineering? It is things like awareness training. And then hardware of data theft. I've seen syndication getting involved into this. And keylogger, we can have hardware and software-based keyloggers. And as you can see in the sample there, the hardware is a USB keylogger, but some of the more devious ones are actually those that are inside keyboards and Wi-Fi enabled. We have disgruntled employees that can actually walk out with data. We seen the Manning case in America with WikiLeaks, and we've also seen Edward Snowden that actually walked out with a lot of data in the organization from the NSA. We have staff with issues, and usually what happens is either drugs, gambling, or family extortion, sometimes purely greed. Now, also, when we look at access control models, this is where the theory starts, and actually this is a nice part. We have discretionary access control, DAC. The important aspect about discretionary access control that you need to remember is that every object has an owner that controls. The owner controls the permission to the access of that object. In mandatory access control, MAC, the security administrator defines a central policy that is guaranteed in principle to be enforced for all users. So in discretionary control, we have the user of the object, the owner of the object, that can actually control, and the other one is with a policy that is published. So it's like an administrator or a system administrator granting or revoking access. Then we have non-discretionary, or also known as role-based access control, where permissions is to perform certain operations which are assigned to specific roles. Front office, back office, a teller at the bank is a good example, and a teller has got certain functionality depending on what's assigned for him or her. And then once the teller moves out of that role, those access rights required are removed. So it's better to actually control that. Discretionary access control, a little bit more detail, is an access policy that restricts access to objects based on the identity of subjects and or groups to which they belong. Now, if you have got some Unix experience, you can look at the user, the group, and world writable files, and each one can have read, write, or execute rights to an object. We can have user-directed discretionary access control, where the user has rights to alter that access, or identity-based access control, discretionary access control, which is access is based on an individual's identity. It is known as the Orange Book C level. The prime usage is to separate and protect subjects from unauthorized objects, and many operating systems use this discretionary access control. Normally, what we see in the Unix Windows environment, Novell NetWare, if it's still used in organizations, Linux, VMS, and MVS, it relies on the object owner to control access. Now, that's reiterated because it's a very important aspect to consider. Mandatory access control, this is Orange Book B level. It is dependent on labels, and there can be external labels such as on printers and also internal labels on the file itself, which determines right and accesses. Only administrators and not the users can make changes to the object level. Consider when you actually buy something from iTunes, there is digital rights management in that. iTunes, Apple assigns the right to the user, you, to use that file. And you cannot change any rights on that file to give it to somebody else. So it has to be assigned from an administrator with a policy. It's generally more secure than DAC. Now, also, there is an overhead because it has to check more access rights. It is hard to program for, configure, and implement. It is based on the need-to-know principle. A downgrade in performance because there is an overhead. Examples of external labels include things like unclassified, confidential, secret, and top secret, where all outputs must have a sensitivity label. For example, print jobs, tapes, and backup medias. Now, also, there's an issue around this such temporal or time-based isolation, meaning that if I log onto a system, let's again put me in a bank environment, and I want to do Forex transfers. I can only do Forex transfers when I log in the morning and actually do from 8 o'clock in the morning till 3 o'clock in the afternoon. And that is time-based. Any side of that, it will not happen. Another example, with all the SIM card swapping happening within South Africa, some of the service providers are allowing their staff only to perform SIM swaps after 9 o'clock in the morning until a certain time. Nothing before and after, because most of the frauds were taking place during that time. Also, role-based access control model, we have a central authority which determines access based on organizational policy. Think banking terms here, my teller, my front office, my back office. We can have hierarchical role-based access control, such as static separation of duties, SSD, and also dynamic separation of duty, DSD. Now, static has been defined, dynamic based on your rights and possibly time of day or any other criteria. 3 primary rules are defined. We have role assignment, role authorization, and permission authorization. And also what we can do, we can look at RBAC to create a lattice-based access control, such as a matrix. So RBAC is a superset of LBAC. Then rule set-based access control. This consists of access enforcement functions, an access definition decision function, access control rules, and access control information. So access is based on a set of rules that determine authorization. The information owner creates the rules that specifies conditions and privileges for subjects. Mediation mechanisms enforces the rules to ensure authorized access. For example, a program and it intercepts every request, compares it to its user rules, and make decisions to authorize access. At ring 0, right in the middle of the operating system, a security kernel is a very good example of that. Now, capability-based security. Now, this is an interesting one, where a capability, also known to some systems as a key, is a communicable, unforgeable token of authority. It refers to a value that references an object along with an associated set of access rights. This is based on the principle of least privilege. The example I can give you here, if you have Unix experience or Linux experience, when you log on to the Linux operating system, your user ID is located in the password file, which is in the etc directory. There's another file that you as a user cannot access, and that's called the shadow file. This contains the encrypted password. Now think about this. When you log on, you actually have rights, or the daemon or the service logging on for you assumes the right to read from the shadow file to compare your password with the encrypted hash. Now, you never have access, and as you can see, it actually suddenly gives you, the daemon, on your behalf, right to read the file to compare it. At no point in time do you have access to the shadow file. Now, also what we're trying to do from a business point of view and international standardization is define For access control, and later you'll see from a privacy control, specific languages. Here, the XACML, which stands for Extensible Access Control Markup Language, which defines a declarative access control policy language implementing in XML and a processing model describing how to evaluate authorization requests according to the rules defined in policies. A very good example I can give you here is a rule that states, allow access to a resource with attribute web service if the subject is the employee and action is read or write. Now, there's a link for, if you want to go look at the request for comment 2904. However, as you can see here, it makes it much easier from our point of view to read as a human what the access control system is trying to say to us. Right. Now, when we look at the access control matrix, this is a very, very, very simple example. We have subjects on the one side, and then we have objects on top, or call severe subject. Now, if one requires access to another, here it is either you've got full access or you don't have any access. So the access control matrix defines either a true or a false. There's no limitations on access. There's no directional flow on the access, how the data flows. So this is a simple way of looking at systems. However, when we start looking at the access control, and there's an access control matrix defined, we can use what they call the Graham-Denning 8 rules. So although you might see 6 here, let me just explain, there's actually more than 6. The Graham-Denning is an information access control model which operates on a set of subjects, object rights, and access capability matrix. Now, the first rule there tells you how to securely create an object. The second rule, same line, how to securely create a subject. So those are 2 rules. Then how to delete an object subject, read access, grant access, delete, and transfer right access. So those are the 8 rules when we actually look at that. Now, if you've got the Sean Harris book, it is defined on page 384, so you can actually look at how they're implementing there. Now, the access permissions, and our Unix have got quite a few. As you can see, if you work on that before, there's 8 types of access permissions, and Windows a little bit more. And it's trying to do additional issues such as single sign-on. You'll see that later. Now, the capability table, so when we look at the previous one, we're going to take the access control matrix, then we're going to look at the access permissions, where the rows are capability lists. It's my subject access permissions, and my column is my control lists on the objects. So as you can see here, very similar to access control matrix, but now we have a capability of what a subject can do an object. Then extending this further on and just doing it into a production environment, we can know this is known as the access control list, and this is the most common implementation of a discretionary access control. For the guys who have Cisco router experience, you'll know that you'll define those groups and the ACLs or the access control lists on them. Some nice experience there. Also, this can be implemented using access control matrices with access permissions, such as the capability table we saw earlier. Define the subject access to and access permission to objects. Then a constrained user interface, purely what that means is that the menus, if I log on to an application, I can have certain accesses or not. Database view, I usually say to the guy, know some SQL. If you know some SQL, it is very good, not just for a CISSP exam, any technical exam, but in future if you're doing any auditing on systems or security reviews. A physical ATM or a cash dispenser known in other countries also is a constrained user interface. And encryption, such as EFS, is also a constrained user interface, meaning that I can only see the data once I have entered my password. When you actually look at a PKI implementation for EFS, you need to consider key recovery agents. If you're on a Windows machine and you encrypt your directory, any administrator can still have access to that data and any administrator is known as a key recovery agent. Content-dependent access control is based on an attribute in the data. A manager has access to information of his staff. Human resources have access to all staff. In this type of control, the value and attributes of the content that is being accessed to determine the control requirements. For example, hiding or showing menus in an application, views in a database, and access to confidential information are all content-dependent. Now, when we go a further step and we don't want to use just passwords, biometrics identifiers are a distinctive distinctive and measurable characteristics used to label and describe individuals. Biometric identifiers are often categorized as physiological versus behavioral characteristics. The effectiveness is measured in a crossover error rate. So when we look at a false rejection, which is type 1 errors, and false acceptance, which is type 2 errors, as you can see from this example, you have the crossover error rate here at basically 2%. And the lower the crossover error rate, the more accurate the device becomes, and of course, how more expensive it becomes. There are examples of biometrics such as a retina scan. Now, as you can see here, this is the back of the eye with the blood vessels, and the blood vessels is very similar to a fingerprint, that every person's is different, and it doesn't change over time. The disadvantage of this could be that if you have any eye infection, such as conjunctivitis, it may alter the characteristics because it might be more emphasized. The iris scan, it's looking on the outside of the iris. As you can see there, the blue part, the iris of this image, it will look at certain points and create a vector. Fingerprint, any cross turns and forks within your fingerprint, it's identified as a node. These are connected and create a vector and creates a number. Hand geometry is another example of fingerprint. Facial recognition, as you can see from that image, there are vectors created. Now, the other one, the second one that you see here, it's a study, but it's not for facial recognition. But what it does, it goes a step further and says, listen, based on how the face looks like, and this is defined in the Boston Globe, it's some study that was done. It says that some facial features make you less trustworthy compared to others. Now, just putting it out there to understand that there are further studies around this. Another issues could be anything like voice recognition, keystroke dynamics, signature dynamics, palm print itself, your silhouette as you walk through a tunnel, and gait analysis, and that's how your pacing of the actual steps are. Now, when we consider biometrics, we can worry about things like enrollment time. It may take a long time to register a user. Also, the throughput, how long to be authenticated, depends on the hardware in the back end. Now, there's an acceptability level that some users don't like it because there are privacy issues, Also, physical comfort, the laser scanning in the eye. Also, the fear and unknown and distrust. Not touching a device because somebody else has touched it and I'm scared of bacteria. Now, when we look at centralized and decentralized, important here when we look at AAA or authentication, authorization, accounting protocols, we have the following solutions. We've got Radius that was developed by a company called Livingston. However, it's open source, and many products utilize Radius, which stands for Remote Access Dialing User Interface. It uses UDP based frame protocols, also SLIP or serial line Internet Protocol, and PPP, that is point-to-point protocol. It's in a client-server configuration, and if you've used Microsoft in a remote access services, Radius is key into this. Then another vendor, Cisco, has developed a system called TACACS, which stands for Terminal Access Controller Access Control System. And the subsequent development is called TACACS Plus, and it's an enhanced version of TACACS, proposes a standard TCP-based transaction, includes CHAP or Challenge Handshake Authentication Protocol or Password Authentication Protocol. Now, Diameter was developed to address some of the limitations of Radius. You can read RFC, Request for Comment 3588, which defines access for mobile devices, and it also uses UDP transport in a peer-to-peer configuration. When we look at single sign-on, the question is always, why do we have single sign-on? What is the objective of single sign-on? And I can guarantee you here, at the end of the day, it's purely for human ease of use and got nothing to do with security. Now, single sign-on can be Kerberos-based, and then Sesame, which stands for Secure European System for Application in a Multi-Vendor Environment, was developed to address some of Kerberos's weaknesses. It can be smart card based, can be one-time password generated based, and then also you have operating system like Windows that has integrated Windows authentication. Now, Kerberos, as you can see from the slide here, you have a Kerberos domain controller, a KDC or Kerberos distribution center, which is normally part of the domain environment, Windows domain, on your domain controller. And this will act to determine if a user has access to a resource. Once it is determined, it will grant it a ticket. That ticket will be used for a certain environment. When you think about single sign-on, Kerberos, and anything like this, the most critical component for me here is the physical security of that KDC. If that KDC is compromised, the environment is susceptible to either man-in-the-middle attack, and it is not trustworthy. Now, Kerberos has a key distribution center. As I said, it has to be physically secured, but Sesame improves key management, and that's the weakness that we have on Kerberos. It uses both symmetric and asymmetric key for data exchange, and then it's an extension of Kerberos which offers public key cryptography and also role-based access control capabilities. Now, when we look at centralized access, we have Radius, we've seen that from Lillison. We've got TACACS and TACACS Plus from Cisco. You can read the RFC 1492 if you want to. We've got TCP UDP on port 49 and XTACACS, which is extended TACACS, which is now decommissioned and quite an older one. Diameter, and to me it's quite hilarious because diameter equals radius times 2. So it says, hey, I'm better than radius. It's an alternative to radius, and it uses TCP and not UDP, so it's guaranteed delivery. Now, when we look at identity and access management, technological definition here, it says that the process and technology to manage information of all external and internal users. The challenge is that we have decentralized and disparate systems. So it can be legacy that we can't integrate into our identity and access management. Technologies are designed to centralize the management of those identities and directories and mechanisms to manage the profile of the users. Some complexities, we can have complex environments, disparate systems that's difficult to integrate. We have manual user provisioning, such as redundant users. We have ghost employees to commit fraud and actually create multiple employees to one user taking all the salaries. Compliance with legal requirements, so sometimes it says we have to do it and sometimes not possible. And outsourcing risks, such as contractors and consultants. They are normally not on our HR database, and this makes it difficult to have start locking that down. Challenges are definitely things like scalability, how big the organization is and how we adapt to that. The consistency, does it look the same when I log on to different systems? The reliability, my usability from an end user point of view, and efficiency. Can I actually implement that quick enough? What's the resource requirements? What we need to worry about this is, an example for me is the Data Protection Act. If you have a identity management system and the main company is in Germany and we have a company in Africa, there's a lack of trust between the EU and other countries like in Africa, and they don't want certain data to go across the border without going through the data, defining requirements, and even ombudsman. So this can be some of our challenges as well. The types of principles that we can use is the user access paradigm, also service access. Service accounts within the environment from a lower level, do they log on into the identity and access management? And also raises issue of privacy. Online social networking, you'll see some of the systems say, oh, well, you log into my environment, I use your Facebook or whatever account, LinkedIn account to log in here. Now, we need to worry about that. Will a user use his organizational data, say Facebook data, and give data out there from an organization? Types of data to include. Again, the Data Protection Act comes into play. On the American, we've got the Safe Harbor Act. Make sure we don't actually put data out there on the outside that is not required. Now, when we look at identity access management lifecycle, this is also a challenge, how quickly we can implement that. The benefits we can get from an IDM is definitely my risk management. We know what objects and subjects I've got out there and what access they have to each other. We can have productivity increase, which means we can monitor user across all boundaries. And once this is done, we can actually have a reduction in headcount because you see that we don't need some users. Some technologies out there, just an example here, we've got Active Directory such as Windows, eDirectory from Novell Netware, LDAP, also other things like SAML, Security Access and Markup Language. We have OAuth and OpenID. Trust, RBAC, and also at the lowest level, or the most common that users use, is password managers. Now, when we look at monitoring and management, we can have intrusion detection system, but there are different intrusion detection systems we have to worry about. We can have network-based intrusion detection. However, that requires port mirroring, network tap, or spanning port, depending on the vendor that you have in the background. They all mean the same, because a switch will switch only between two ports at the MAC level address, at the media access control. Thus, you need a port that mirrors all traffic on the network to sniff that. We have host-based IDS, which is a software agent running on top of the host. We can have stack-based IDS, look at the TCP IP stack and see number of connections, utilization, and also application IDS specific to an application such as Oracle, IIS, any web servers. Then in an IDS, we can have detection techniques. Some are statistical anomaly based. For example, suddenly network bandwidth. If I have suddenly huge bandwidth utilization, something can happen in network that's not. So it's statistical anomaly. CPU usage, suddenly it jumps at 100% for a while. Connected users. If I know I've got only 100 users in my organization and suddenly I have 500 or 1,000 connections, so we need possibly an attack taking place. Another issue can be signature based. Now, one of the open source IDS solution is Snort, and you can implement that, but the problem is you can have a lag with development issues. So if signatures are updated, how do you update it within an organization? Do you have an automated process? And those updates, like antivirus software, is really a management issue. You can have heuristic scanning, such as a vendor dependent in a sandbox environment. Oracle is a very good example where they actually have all queries to a SQL database and go through a process and making sure that they are not vulnerable, containing vulnerabilities, and if not, it will allow it to go in. But also, when we look at intrusion prevention systems in an environment, basically an intrusion prevention system is an IDS with a proactive firewall. The advantages here, it can detect an intrusion and disable that threat. The disadvantages is usually very expensive, it's complex to implement, and it can also be used by a hacker to create a denial of service in an environment. Now, another example I'm just putting in here is audit trail monitoring. Example I saw many years ago was Network Flight Recorder, written by Marcus Runham. The audit trail is a record of system activities that captures systems, network, and applications. And this audit trail can alert security officers of suspicious activities, details of non-conformance or illegal activities, and also provides information for legal proceedings such as the forensics. Now, other products in this space, if you look at it, is ArcSight from HP. Now, I don't recommend any products here, but it's actually quite good to see what is out there. Splunk is another one for an open source environment. The problem with these products is that the data volume needs to be set at the clipping level, because this can, depending on the size of the organization, be quite a lot of data, and you have to manage that. We need personnel training to identify non-conformance or any illegal activities, so this is also an issue. We can store and archive. This may be a legal compliance requirement. One company I actually had a discussion with say, well, we'd rather not log because the fine for not logging is actually less than the cost will be for us to implement adequate logging and recovery. Now, the last item we look at is access control assurance. This is where we look at the access control system and say, is it working as designed? So we can do audits. We can do log-on monitoring to a central environment. Asset management. There's software that does that for you on a technical level, but also assets could be all my users, my HR, my human resources database, the workflow and the processes, and business functions. And then finally, we can actually do some penetration testing. We can have Tiger and Spider teams, internal and external. The possible pitfalls with the penetration testing is that we can break systems. Although, do a change control, and if you break it, we identify weaknesses, because that will be a threat in your organization. Areas to test, depending on the threat management that you actually do, you can actually look at your persistent threat analysis and see where you actually have to look at. But in real terms, you have to look at everything, but you can start looking at your high risks in your organization. We can do external testing, blind and partial knowledge. Blind meaning I don't have any information in your organization, and partial knowledge, I can actually get some information from your systems. Internal, we can have full knowledge. targeted to an environment. Blind, we don't tell the user that we're coming in, and double blind, we don't tell IT even that not defined. We just actually have a senior executive that will actually make sure that we are authorized and have our what they call a get out of jail free card. So if we get caught, hey, this is part of the process. Then also future risk, when we look at the networking side a little bit more in detail, we can actually have cloud computing, access control methodologies based on services. So somebody would like to sell you access as a service, redundancy of passwords, because password really means nothing, and because they're easily cracked, and they have the attack methods on passwords is getting better and better. If we look at graphics cards being used, instead of 1 million attacks a second, we can actually have 10 billion attacks a second on some of the machines now. And also DNA is possibly a biometric public key.